Hello everyone and welcome to Network Playroom. This is another quick study notes video and today's topic is PGP operations. And like in my previous video, I'm continuing my studies in Cisco Learning Library. I don't have my tweets open on the screen here because I actually posted only one tweet about this section. And that is because I've covered some of the topics in this section previously on my channel and on my Twitter account. So we're gonna do this one a little differently. So in this video, we're going to talk about PGP data structures and PGP message types. So I've already made an in-depth video about PGP message types, so I'll go over them briefly and leave a link in the description so you can go watch the other video with more detailed explanations. And I've also created some nice diagrams which are available on my website, and we'll look at those later on as well. But before we get into that, let's talk about the PGP neighbor table, the PGP table, and the IP routing table. Technically, the last one is not a component of PGP, but it is closely related to the operation of PGP. So let's get started. So a router stores PGP information that it receives from and sends to other routers in the data structures. And the PGP neighbor table keeps track of the state of the PGP peerings. If you recall from my other videos, PGP must explicitly configure each neighbor to establish adjacencies. Unlike IGPs, PGP is never enabled on an interface and it does not discover neighbors automatically that way. Now, after the PGP session is formed, PGP sends periodic keepalive messages to maintain the adjacency. And the PGP neighbor information is recorded in the PGP neighbor table. And you can view the PGP neighbor table with the show IP PGP neighbors command. Now, if you look at the right side on the screen here, I have some of this command output available from a Cisco command reference. So we'll actually look at that and try to figure out the neighbor relationship between these two PGP routers. And actually this output is lengthy, so we'll try to pick out the most important parts. So you can see the command is show IP PGP neighbors, and it specifies the neighbor's IP address. So let's actually draw some routers here. So we have a router. Oh, that circle is terrible. Okay, so we have two routers here that are neighbors. Now, we know from the command that this neighbor is 10.108.50.2, and also it says on the first line here, and it says remote AS1. So we're looking at this line here. So remote AS1, and it says internal link. Now internal link means IPGP. So let's draw a connecting line here. So this is actually all in AS1. And this is this relationship is IPGP, which we can tell from the internal link part on that line. IPGP. Alright, let's see what else we can find. Remote, we can see the remote router ID on the line below. Let's write that here as well. 192.168.252.252. The PGP state is established and the connection has been up for 24 minutes. Here on this line, you can see the neighbor capabilities. We haven't covered those in my videos yet. If we go down a little bit here, you can actually see the different PGP messages that have been sent and received. We're gonna look at those next. Let's see, what else do we have here? All right, this is an interesting part. So see here, localhost and local port, foreign host, foreign port. So actually from this one we can tell that the address on this router is 10.108.50.1. And if you remember, PGP forms a peering over TCP port 179, and it operates as a client-server model. And from these port numbers here, we can tell that this guy is the server because that's using the port 179, and the remote router is using port number 42,689, like this. So as you can see, this output is quite long, and you should just kind of cherry pick the most important information from here. Alright, let's move on to another command output, because this is actually a good way of identifying the PGP neighbors as well. So if you look at this section here, so these are actually different routers, or this is a completely different setup. But I just wanted to show you this because it shows the neighbors in one line each, and then there's some additional information that we can cover in another video. I've actually created this new series where I explain command outputs. I've posted something on Twitter already, but I'm planning to turn those into videos as well. So I don't want to cover it too much here, but we'll probably come back to this command in another video. But again, I just wanted to show it to you guys briefly, because this output also shows you the neighbors, and you don't have to go through that long show IP PGP neighbors command output. Because of course, if there were more neighbors, then the output would just continue on. Right now, this output has actually specified the neighbor IP address. Okay, let's carry on to the next part in this video. So after two PGP peers have completed the session establishment, they exchange routing information. Now each router collects these routes and places them in the PGP table. And all PGP routes will be in the PGP table. Then the best route is selected for each destination through the PGP best path selection process, and it is offered to the routing table. We'll look at the IP routing table next, but you can view the contents of the PGP table with the show IP PGP command. So I have it open right here, an example output, and this is what it would look like. So again, you can see those different networks listed here, and then some other information like the next hop metric, which refers to the med value, and local preference weight, and then the AS path. If you see empty lines like right here, that means that this network above it was learned from different neighbors. So you can see here that the next hops are different. And right here, this line is the AS path. We've covered AS path in my previous video. And this looks slightly strange because this has the AS number 10 twice. And if you remember from the other video, AS path is actually used as a loop detection mechanism. So if you see your own AS number in the AS path list, you're gonna ignore that update. And normally you would only insert your AS number once when you advertise the update to an ePGP peer, but there are ways to apply your own AS to the AS path multiple times, which we haven't covered yet. But if you think that looks a bit strange, it kind of is. That's not default behavior. Again, I will probably cover this command in more detail in another video, so we'll come back to this as well. So a quick recap before we move on to the IP routing table. So number one, there's the PGP neighbor table. Neighbor, I don't know how to spell that. Neighbor table. And you can view that with the show IP PGP neighbors command. And then there's the PGP table. And you can view this with the show IP PGP command. So now finally, let's look at the IP routing table. So the IP routing table consists of the best routes to reach networks, and the best route is based on the administrative distance value. So how this works is, if the same network is learned by different routing protocols, each of them will offer that route to the IP routing table, and the IP routing table will accept the most trustworthy one. And the administrative distance indicates the preference or the trustworthiness for different routing sources, and the lower value is better. So for example, ePGP routes have an administrative distance of 20, and iPGP routes have an administrative distance of 200. And this is by default. Now in this case, ePGP routes would be preferred over iPGP routes because of the lower administrative distance value. So let's write that here as well. So ePGP default AD is 20, and then iPGP AD by default is 200. Now in fact, if you consider the administrative distance values, ePGP routes are the most preferred for external routes, and iPGP routes are the least preferred for internal routes. And why am I saying this is because of the default administrative distance values. So for example, for EIGRP, the default administrative distance is 90, and for OSPF, it's 110. So those are both lower than iPGP. You can find the default AD values by Googling or looking at Cisco documentation. It's not so important to know what those exact values are. It's more important to understand the concept. So that's how it works. Now you can view the IP routing table, also known as routing information base, or RIB for short, with the show IP route command. So let's write down our third component, so the IP routing table. And this is viewed with the show IP route. I have some example output here as well, and this is probably familiar to many of you. And actually the guide I've used right here must be old, really old, because if you look at the route codes right here, it says E. Have you ever seen E before? I certainly haven't. And actually, if you try to find it in this section where all of the codes are supposed to be explained, it's not here. So we have to scroll down a little bit, or actually maybe the information was above. Yeah, sorry, we have to go above a little bit. Where is it? Now I can't find what I'm looking for. Nope. Here it is. So I was right, we had to scroll down. So codes. And then... No, now I'm confused. I swear I've seen E here before. Okay, I cannot find what I'm looking for, but I'm sure I checked it before. I read it before that E stands for IGP, which is the predecessor of PGP, which you should not see anymore. So it's kind of funny that now we can see IGP routes right here. That doesn't matter though, like I just wanted you guys to get an idea what the IP routing table looks like. We don't have to worry about the specific details right now. We can come back to this later as well. I'm actually in the process of setting up a GNS3 lab so I can show you this stuff on the command line instead of just drawing on my whiteboard here and trying to explain it to you. So hopefully in the next video or in the future videos coming soon, I will be able to show you hands-on lab exercises and cover these different topics. Alright, so now let's talk about the PGP message types briefly. So PGP has 4 different message types. There's open, update, keep alive, and notification. Now actually let me open up this page here where I have the diagrams that I've created previously. I've posted this on my Twitter account and also on my blog, on my website at networkplayroom.com. So each PGP message has a fixed size header, and there may or may not be a data portion following the header, depending on the message type. Now let's start with the keep alive message, because a keep alive message consists of only the message header. As you can see here, the PGP header, which is also the keep alive message, is very simple, not many fields in here. And the keep alive message is exchanged between PGP peers to determine if those peers are still alive. So this is comparable to the hello protocol in IGPs. Now after the TCP connection is completed, the PGP open message is used to establish a PGP adjacency. Now both sides negotiate session capabilities before a PGP peering establishes. So this is what the PGP open message looks like. So again, the header is there. I've tried to color code it in these diagrams to make it a bit clearer that this is the same in all of these different packet types. And in the open message you have much more information, many more fields than simply in the header. And then, yeah, you can look at that, or you can watch the other video where I explain this in more detail. I don't want to get carried away with explaining those fields right now. Now let's move on to the PGP update message. So the update message is used to transfer routing information between PGP peers. An update message is used to advertise feasible routes that share common path attributes, or to withdraw unfeasible routes from service, and both can be done in a single update message. So you can see the update message on this diagram here. And actually, one interesting thing to note about the update message, that it kind of has a reverse logic. So let me explain. Now in IGPs, you have a network, you have a destination that you want to advertise. Let's say, let's write something here. You have an update, like you want to advertise 192.168.1.0/24. So then you have this network in this update, and it has some kind of metric. I don't know, let's put 100, for example. And so how this differs in PGP is that it actually has a path attribute centric approach. So what it means that you build this update message and you collect all these common attributes, or these shared attributes, and then you attach the network layer reachability information to that update message. So in PGP, it's a little bit reverse, if that makes sense. So you could have like AS path 65,001, for example. Then let's say you have next hop 10.1.1.1 and origin code, let's make it I. And then what happens is, now you have these attributes, and then you attach this network here, 1.0/24. And if there are other networks that share these attributes, they would be added here as well. Let's say 172.16.10.0/24. Does that make sense? Let me know in the comments. So now let's move on to the PGP notification message. Right here you can see the diagram. So the PGP notification message is sent when an error condition is detected, and the PGP connection is closed immediately after it is sent. There are various error codes and subcodes that can be in the PGP notification message that can cause the connection to be closed. I'm not going to cover those in detail in this video, but you can look at the RFC if you'd like to know more about the different error codes. So again, as I mentioned before, I've already covered the PGP message types in detail in another video, and the link will be in the description if you want to learn more. But that's it for this video. Thank you for watching, and I'll see you next time.